Oh.
Welcome, Jamie. Alright, so thinking back over it, just so that way Jamie has a fair chance as well, because they were asking questions, Jamie. Alright, who came up with the plum pudding model?
No, J.J.
J.J. Thompson. So make a note for him. Did plum pudding model. Now what was wrong with it?
Planetary model.
It was all positivity, and they put the
Positive?
electrons in one place, like a big cookie.
That works. So just in case Jamie couldn't hear, because the idea of one big positive charge with the electrons embedded through it. So you shouldn't have anything bounce off of that, but we do. So that's why we knew that the plum pudding model was wrong. Alright, so with the planetary model, who came up with it, Quentin? Rutherford. Yes, Rutherford. Alright, what's wrong with it?
It says that the electron will go in like orbit and will lose energy.
Good job, and they would collapse towards the center. Alright, the Bohr model. Niles Bohr. What did his model say?
It's stuck in one place. The orbit's stuck in one place.
Alright, and so they're locked in an orbit or in that line. So what do we call the lowest orbit at the side?
Wait, Rutherford, that was the same thing, right?
He didn't have them locked in. Yeah,
Okay.
he would have them slowly lose over time. So that's the difference. Is Bohr said, okay, no, they're locked in now. They can only move from one spot to another by losing energy.
Rutherford's, what was wrong with it again?
Planetary model, that it didn't have them locked in, so they would eventually collapse.
Okay.
That's more of a physics thing, but yeah, they would eventually collapse. Alright, what do we call that lowest energy state as a side note?
The lowest energy.
Ground state, and then everything above that is?
Excited.
Excited. Alright, so they knew, okay, that's not quite right. So who proposed matter waves as a side note?
Lawson Charles Maxwell?
Nope.
Bohr.
Not Bohr.
Born.
Not Bohr.
De Broglie.
De Broglie. Louis De Broglie. Who came up with the wave mechanical
come up
model
with?
for this state? What?
What do you come up with?
Matter waves, that all matter moves in that wave. Alright, who came up with the wave mechanical model or standing wave?
Bohr.
Wave mechanical model.
Bohr.
Nope.
Bohr.
Nope.
De Broglie.
Nope.
No. What was I saying?
Schrodinger, remember
Schrodinger.
that one?
Schrodinger.
Yeah, make a note for him. Wave mechanical model, that standing wave. Saying, okay, that they move in that up and down pattern as they're going through it. Let's see. Alright, who came up with the uncertainty principle?
Heisenberg.
Heisenberg. What does the uncertainty principle say?
Things are uncertain.
You can't
Which
measure.
part?
You can't measure the You can't measure
Speed
the
and
velocity.
speed and like velocity. Yeah.
Okay, speed and velocity are basically the same
You
thing.
can't measure
and, like,
velocity and
distance.
distances.
Okay, not distances,
Speed and location.
location or position. So that's the idea behind it. Alright, who came up with the model that is the best one today, the electron cloud model? Who came up with that one?
Born.
Born. Now, what does he call those regions of high probability? Because they're moving up and
Orbitals.
down? Orbitals. And because of the uncertainty principle, we're not sure where they're at. Alright, anyone have any questions about that? Alright, I'm
One
gonna
more
go
thing.
with what?
One more thing.
What's your last question?
Metallic and ionization. What? Name the difference between
Okay,
those two. Real quick.
ionization energy, that's the energy to take off an electron. So if you have high ionization energy, are you going to lose electrons easily? If it takes a
No.
lot of energy, okay. So are you considered a metal if you don't want to lose your electrons easily?
No.
No. So if you have high ionization energy, you have low metallic character. What if you have low ionization energy?
High metallic.
High metallic character. So they're opposites. Alright, anyone have any questions about that? Alright, clear depths of everything. So you just need a pen for this one. You're far enough away to where you don't need a cover sheet. Clear your desk, Ethan. Put it away, you gotta go. Ethan's really got that away. Alright, so that first section is all of it is multiple choice, but this is application. Read it through it and think it through. So, what is the full electron configuration of argon? If you flip to the last page of your test, I gave you the copy of the periodic table. So if you want to go ahead and tear it, so that way you can have it at the front of the page, you can, but it's there for you. So Jamie's, yours also has it as well. So if you want to tear it, so you can have it there, so you can look at it, that's fine. So I'm just asking, what's the full electron configuration of argon? So go through and figure out, okay, where's argon? And then go through it. The next section, I'm asking what's the full electron configuration of krypton. So again, go through and solve it. After that, I switch over onto the shorthand method for it. So just making sure you know how to do them. What?
I tear it off.
You can tear it off. Alright, looking down at question number 4. Alright, I'm asking for the 4 sections of the periodic table. So if you look, you'll notice lithium is top left. Francinium is bottom left, fluorine's top right, and then acetane is bottom left.
Where are you?
Question number 4. So, I didn't put them in alphabetical order because I'm going, okay, is it top left, top right, bottom right? So I picked elements from the corners. So that's why those are not in alphabetical order. So if you're sitting there wondering why does it look like that? That's the reason why for it. Alright, and then because mentally you have to switch over to that, I just left all of it like that to where it looks like A, B, C, D for that section. So just be careful as you're going through it. Alright, so most of these are applications, so think through. I bolded the key terms trying to help you to know what thing you're talking about, or what I'm asking. Alright, does anyone have any questions about that so far? So I don't want you to get confused and just psych yourself out. Alright, next page. Again, read through everything, pay attention to what you're doing. Alright, number 23 is I'm asking you how many are in iron's outermost shell. Look at the periodic table, you can find iron, figure it out, or you can just use electron configuration to figure out. You can use electron configuration for all of them, but most of them you probably memorize, like fluorine, based on which group it's in, how many it has. So that's why those should be a little bit easier. Alright, completion, 28. What is the Lewis symbol for sulfur? Okay, be sure remember how to do a Lewis symbol and to do it correctly for it. Don't try to just do it super fast. Alright, anyone have any questions about this so far? Okay, last page. Modify true, false. If the atomic portion makes the statement true or true. If it makes the statement false, write the words that would make the statement true. So should you write false anywhere in there, Ethan?
No.
No, fix it if you think it's wrong. Alright, essay. Compare Rutherford's, Bohr, and Bohr's model of the atom. Include a brief description over each and explain why Bohr model is the best and accurate as of today. Try to give me as much information as you can for it. So give me as many details as you can. Describe, okay, here's the different models.
8 points.
Here's what's wrong with them. 8.
8.
But keep in mind though, if you describe, okay, here's Rutherford's, here's what it looks like, here's the problem with it. Here's Bohr's, here's what it is, here's what's wrong with it. Here's Bohr's, here's what it is, and here's why it's the most accurate today. Alright, anyone have any questions about that? Don't forget a topic sentence though.